Limiting reactant calculations. In order to talk about limiting reactants, we first have to define some terms. Stoichiometric amounts. This is when you have exactly enough of each reactant to consume the other with nothing left over. Now, when you have stoichiometric amounts, there is no limiting reactant and no excess reactant. But usually, that is to say, stoichiometric amounts are a special scenario. Usually, you have a limiting reactant that's completely consumed, and then the reaction stops. This is lower than a stoichiometric amount. And you have an excess reactant that remains after the reaction stops, because this is higher than the stoichiometric amount. So, how do we do it? Let's take a look. The most effective way to determine the limiting reactant is to compare what you have, that is, your given quantity, with what you need, and the amount you need you determine via stoichiometry. This will give you one of two outcomes, right? Either what you need, what you calculate via stoichiometry, is greater than your given, what you have, in which case that particular reactant is limiting. Or you can have your inequality symbol in the other direction. In other words, you have more than you need. That is, your given is greater than your calculated amount, then that reactant is excess. Let's see it in real life. So here's an actual limiting reactant question, and that is, what is the limiting reactant when 50 grams of aluminum reacts with 100 grams of nickel 2 chloride? And you're given a balanced chemical equation. 2 moles of a solid aluminum reacts with 3 moles of nickel 2 chloride to make 2 moles of aluminum chloride and 3 moles of nickel. There are two given quantities, and we can start with either one. Let's say I want to determine what aluminum is. Is aluminum excess or limiting? Okay, so I have 50.0 grams. How much do I need? To calculate how much I need, I'm going to do stoichiometry starting from nickel 2 chloride. So here's a map of the stoichiometric calculation I'm going to do. I'm going to start with my 100 grams of nickel 2 chloride. I'm going to use the molar mass to convert it to moles of nickel 2 chloride. I'll use a mole ratio to get to moles of aluminum, and then I'll use the molar mass of aluminum to get to grams of aluminum. So here I've set up my calculation. My first conversion factor converts grams of nickel 2 chloride to moles of nickel 2 chloride. Grams cancel. The second conversion factor takes moles of nickel 2 chloride and converts them to moles of aluminum. The third conversion factor converts moles of aluminum to grams of aluminum. So when I do the calculation, I get that I need 6.939 grams of aluminum. That is much less than the 50.0 grams that I have. Right? So I need less than I have. In other words, I have more than I need. Aluminum is the excess, which means that the nickel chloride is the limiting reagent, the LR.